I'm Mike Mulkey, Software Product Marketing Manager at Sun Microsystems, and I'm here today with Will Aiken, Principal Engineer from Intel Corporation, and Dennis Vilfert, who's a Senior Product Manager at Sun Microsystems. Sun and Intel, some exciting technology. What's going on, guys?
Well, Dennis, I brought you a present.
Oh, thank you, Will. Well, I'll tell you, Mike, we're very excited to be here today because this is about the most exciting thing that has happened in storage in the last 15 years. What I have here in my hand is the equivalent performance of 100 disk drives.
Oh, really?
Yeah, 100 disk drives. And the best part is it only takes as much power as my kid's nightlight, 2.5 watts, you know.
Wow.
As a comparison, if I had to get the same performance out of 100 disk drives, we'll talk 1.75 kilowatts. That's as much as your toaster or your iron at home.
Wow.
So not only is solid state very, very fast, it's very, very, very power efficient.
So that's about 1/5 the power of a hard drive.
Wow. Yeah, it really is.
So Will, this is pretty exciting. There's got to be some big solutions behind this for Intel and solving customer problems. What's going on?
Intel identified through its manufacturing capability of NAND that storage has a bottleneck today, and having NAND storage and empowering devices around NAND storage can break down that bottleneck. So for the enterprise space, developing products like this was just a no-brainer. We had to do it. And those are the type of things that we're going after right now, and we have a roadmap of capabilities in the future.
So Dennis, how's Sun involved in this? Where's Sun's part?
Well, obviously, as you know, Mike, we are a server company, amongst other things, you know, and one of the things we saw that was going on is our servers was sitting mostly waiting for disk drives, because disk drives had not really been spinning much faster than they did when they first came on the market. The 15K drive came on the market in 2001. Had that kept up with the servers, it would have been spinning at 195,000 RPMs today. And that's completely ludicrous, of course, because you can't do that with a mechanical drive. So once we got to solid state, all of a sudden the server doesn't have to wait any longer for its data. And that, of course, translates into much better performance for applications that are generating value for our customers.
That's huge.
And better utilization of our multi-core processors.
Exactly. Right. As the CPU gets bigger and bigger and we put more and more cores and more sockets in each individual platform, that became an increasing problem.
Now, there's a term I want to interject here. I keep hearing about it with these solid-state drives. Hybrid storage technology. So what's that about? Is that part of the solution here?
Yeah, very much so, Mike. And what's going on here is these disk drives here, which they look like a disk drive, but they're really an array of flash chips, as Will just alluded to. They're not necessarily yet at the capacity points of disk drives.
But we're going to get there.
Yeah, I know that. I know that. That's absolutely true. We're going to get there. But if you take a snapshot of the market today, I can go down to the local electronics store for $200. I can buy a very, very high capacity drive for around a terabyte, going to 2 terabytes next summer. So that's a capacity device. But performance, it is not where it needs to be. So this is great for performance, and disk drives are great for capacity.
And so this concept, from a roadmap standpoint, where do you see it going, Will?
Well, there's a few challenges. One is to try to get these utilized in the enterprise environments, and that's where Sun comes in. It's a direct fit into the ZFS environment, and allows us to do quick time to market and product development. So where Intel is we're supporting these type of activities going forward and actually looking at areas of IOP needs and less power and the ability to be more reliable under harsher conditions. And those are the areas that we're looking at in the future. We're also addressing the capacity roadmap. The lithographies are doubling every year, whereas in hard drives, the capacity is doubling every 2 years. Okay. So we're catching up. It's not a capacity play, but it is a performance play.
So ZFS, I heard a term. I'm from software. How does that play into this? So ZFS is a part of this.
Yeah,
huh?
let me talk a little bit to that, Mike. You're absolutely right. This having just solid-state disks, you know, that's okay. But because they're not big enough, and we need to sort of augment them with large capacities, then what we're really seeing is a split of the usage model. You use solid state for high performance now. That's absolutely true. But you can't afford. It's still a little pricey. You can't afford to have your whole data set on solid state. That might stay that way for a few years coming. Okay. So for now, what we're doing is we're saying, aha. So performance is on solid state. But what about high capacity? If my data set is really huge, but only maybe use a part of it. So what ZFS does so cleverly, it'll automatically cache the most usable data or used data in solid state. And the data as part of your data set, but maybe not used as much, is sitting out on the actual spinning rust.
And you didn't have to make any changes to support
that's
that.
right. That's right. ZFS automatically, just a matter of a few lines of code, changed it. So you set it up, you download ZFS from OpenSolaris.org, and you set up, hey, I want to go to the ZIL, which is the ZFS intent log, and that sets up the write cache. And L2 ARC is our level 2 read cache. You can use that on solid state too as well, and you can build that in shipping today.
Are there any cycling concerns or reliability concerns you run into?
Oh, that's a very good point. That's been some of the fears we've seen, that people are very nervous about the longevity of a flash device. Well, luckily Intel has addressed that in their controller code. So here we're dealing with an MTBF of more than 2 million hours. And that's actually, just for comparison, an enterprise class drive has only 1.2 million hours to call it enterprise. So this is more reliable than this drive.
And at 5 years.
And the economics have got to be huge, right? I imagine the savings behind something like this?
Yeah, the savings per IOP, or input-output operation, is big.
Excellent.
That's true. And when you combine it together with the savings of large capacity drives, you actually see a hybrid storage pool is 1/10 of the cost of a monolithic storage pool in acquisition. And in terms of power, is only 1/5. So we're really not only green, we're also good for the pocketbook, Mike.
That's excellent. Well, we've got a lot more information available for you. Solid state drives, ZFS. This is exciting. If you go to the website, you'll find more information. Thanks for joining us, guys. Thanks for your time.
Welcome.